RS-232 is an older serial communication standard that is commonly used for short-distance communication between computers and peripheral devices such as printers, modems, and scanners. It uses a single-ended signal and supports data transmission rates up to 115.2 kilobits per second. RS-232 is a point-to-point protocol, which means that it can only transmit data between two devices at a time. RS-232 is a serial communication standard that uses a 9-pin or 25-pin connector to transmit data between devices. The 9-pin connector is more commonly used today. Here is a description of each of the pins on a standard RS-232 9-pin connector. 1. CD, carrier detect. This pin is used to detect the presence of a carrier signal from the modem. 2. RxD, receive data. This pin is used to receive data from the transmitting device. 3. TXD, transmit data. This pin is used to transmit data to the receiving device. 4. DTR, data terminal ready. This pin is used to signal that the device is ready to receive and transmit data. 5. GND, ground. This pin is used as the electrical ground reference for the other pins. 6. DSR, dataset ready. This pin is used to signal that the device is ready to communicate. 7. RTS, request to send. This pin is used to request permission to transmit data. 8. CTS, clear to send. This pin is used to signal that the receiving device is ready to receive data. 9. Ring indicator. This pin is used to signal an incoming call on a modem. It's important to note that the functions of some of these pins can vary depending on the specific application and the devices being used. Additionally, the Pinout of a 25-pin 232 rupees connector may be different from that of a 9-pin connector. RS-232 uses two-way communication to transmit data back and forth. Data transmission equipment, DTE, and data communication equipment, DCE, both of which have TXD, RxD, RTS, and CTS pins, are connected to one another. The RTS now creates the request to send the data from the DTE source. Then from the other side DCE, the CTS, clears the path for receiving the data. After clearing a path, it will give a signal to RTS of the DTE source to send the signal. Then the bits are transmitted from DTE to DCE. Once more from a DCE source, the request may be generated by RTS and CTS of DTE sources, which open a path for data reception and provide a signal for data transmission. This is the entire procedure that goes place when transmitting data. The TXD pin of the data sender is connected to RxD pin of data receiver. Data is transferred through this wire using serial communication method. DTR, data terminal ready. Pin of sender is connected to DSR, dataset ready, pin of receiver. This connection confirms that receiver is ready to accept data without any fault. This is confirmed by checking the voltage level of receiver. For receiving the data accurately, the baud rate, i.e. speed at which each data packet sended, should be within the processing capacity of receiver. This is achieved by connecting RTS, request to send, pin of data sender with CTS, clear to send, pin of receiver. Sender send data packets only if receiver is ready to collect. CD and RE is used only with modems. For a data transmitter to send data to a receiver using the RS-232 protocol, the following conditions must typically be met. 1. Both the transmitter and receiver must be configured to use the same baud rate, which determines the speed at which data is transmitted. The baud rate is typically set using a configuration command or by setting dip switches on the device. 2. Both the transmitter and receiver must be configured to use the same data format, including the number of data bits, parity, and stop bits. These settings are also typically set using a configuration command or dip switches. 3. The data transmitter must initiate the communication by sending a start bit to the receiver. This start bit is a logical low signal that indicates the beginning of a data frame. 4. The transmitter must then send the data bits in the correct order, according to the selected data format. The receiver will receive these bits and interpret them accordingly. 5. Once the data bits have been transmitted, the transmitter must send one or more stop bits to signal the end of the data frame. 6. This process is then repeated for each subsequent data frame that needs to be sent. Baud rate refers to the number of signal or symbol changes that occur per second in a communication channel. In digital communication, a Baud rate is the rate at which a signal can change or transition between different states. It is usually expressed in bits per second, BPS. RS-232 is a standard for serial communication transmission of data between devices. The Baud rate for -232 standard communication can range from 75 Baud to 115,200 Baud, although other rates are also possible. The Baud rate used in -232 standard communication depends on the specific application and the capabilities of the devices being used. RS-232 uses asynchronous communication. Asynchronous communication is a method of transmitting data where each character is sent one at a time, without a continuous clock signal to synchronize the sender and receiver. In RS-232 communication, each character consists of a start bit, data bits, typically 7 or 8, an optional parity bit, used for error detection, and one or more stop bits. The start bit signals the beginning of a new character and provides the timing reference for the receiver to sample the incoming data. The stop bit or bits signal the end of the character and provide a brief pause before the next character is sent. Stop bits and parity bits are used in data transfer to help detect and correct errors that can occur during transmission. Stop bits are extra bits that are added to the end of each character to signal the end of a transmission. They provide a brief pause between characters to allow the receiving device to process the data before the 232 is an asynchronous standard. It is typically used for low-speed communication over short distances, such as between a computer and a modem or a serial printer. For higher speed communication or longer distances, synchronous communication standards such as RS-422 or RS-485 may be used, which use a clock signal to synchronize the sender and receiver. In general, RS-232 is designed for short-distance communication, typically no more than 50 feet, 15 meters, at standard Baud rates. However, lower Baud rates and high-quality cables can allow for longer distances, up to a few hundred feet in some cases.